This video shows how you can draw lines on a coordinate system at years 9 and 10. You're given a formula of the type y equals mx plus c, and each time we follow a three-step procedure. We use the formula to find the y values for a small number of values of x. We plot the points for each of those xy pairs, and we connect the points to get a straight line. Let's see it done in operation then. Let's take an example. Y is 2x plus 1. I recommend you do it this way with a grid. That enables you to go back and to check your working afterwards. And we pick a value of x. Let's take 2. 2 is put into the formula 2x plus 1. 2 times 2 plus 1. And that gives us a value of 5. So we have the point x equals 2, y equals 5, which we plot on our graph. X equals 2, y equals 5. Take another point. Let's take minus 2. 2 times minus 2 plus 1 is minus 3. So we plot the point minus 2 across, minus 3 up. And just for safety's sake, we'll take a third point. We'll take 0 because that makes our calculation easy. 2 times 0 plus 1 is 1. And we plot our third point. Now we have 3 points and we can connect them up with a line. If the points don't connect with a line, then you need to go back and check your working. You need to check that your calculation is correct, and you need to check that your plotting is correct. If the formula is of the form y equals something x plus something, then it will always be a straight line. Let's do it again. This time we're going to take y is minus 3x plus 4. Again, we put our grid out, and x equals 2 is a good starting point. Minus 3 times 2 plus 4 is minus 2, so that yields the point 2 across, minus 2 down. Take x equals minus 2. Now at this point we have to be quite careful because we're multiplying minus 3 by a negative number, which of course gives a positive number. If you're not very good with this, use a calculator. Minus 3 times minus 2 plus 4 is 10, and unfortunately that's off the top of our graph. Never mind, we'll find another point to plot instead. 0. Minus 3 times 0 plus 4 is 4, so that's the point. 0 across, 4 up. And I recommend we always have at least 3 points. 4 across, minus 3 times 4 plus 4 is minus 8. So that gives us this point down here. And we have our line. Of course, if we look at minus 2, 10, we can see that that's on the line. So, if a point is plotted that is off your graph, no problem. Just go and find another point to plot instead. Finally, we have to look at fractions. Here's one here. Y is a third x minus 2. Put our grid out. Now if we start with 2, then we have a bit of a problem, because 1/3 times 2 minus 2 is minus 1 1/3, and that unfortunately is not a whole number, so although we can plot it, we can't plot it very accurately. So I recommend when you have fractions that you use the numbers that work with the base, the denominator of the fraction. In this case we'll take 3, because when we take 1/3 times 3, that's 1. Minus 2 is minus 1, and we can plot that as a whole point. We can take 0 again, that yields minus 2, and we can take a third of minus 3, minus 2, and that is minus 3, and we have our straight line. You'll notice that the point that we did have for 2 is on that line, but it's much easier to plot the line correctly if you use the denominator of the fraction to your advantage. So that's all we have to do to make lines work. We can plot more if we want to check. In this case, 6, a third times 6 minus 2 is 0. But in general, you only need 3 points and if they form a straight line, that's mostly enough. What can go wrong? Well, you should plot points that spread around the axes, and this is why. We'll take 2x minus 1. If we take our points 3, 4 and 5, then we do our little calculations, and that yields these 3 points here. We can connect them up with a line. But unfortunately, when you're doing it on a page, it's a bit easy to get a bit of a wobble going on. We might miss low, we might miss high. Very hard to tell when your points are clumped together like that. So, one way to avoid that is to pick a point like -2 that is a long way away from the other points. Then you do a calculation for that. We get -2 is -5, and we can see that our line has not crossed at the right point. So, because we've got a point across the axes, we get a much more accurate picture. This is really important because when we do our marking, we're going to be marked on that. Another thing we shouldn't do is stop the line short, like we've done here. The line is infinite and carries on and should be shown to carry on. The reason is you're usually marked on the intercepts, both the x-intercept and the y-intercept. If you don't show them, you don't get any marks. So don't stop the line short, and pick points that are spread widely enough so that you get an accurate line. Other than that, you can pick any x points you want to get your y points. Let's revise how we do it then. We're going to draw a line. We're given a line of that formula. What we do is we use the formula to find some y values for some x values. We plot the points for each of those pairs, and we connect the points to get a line. If we mistake a point and our line is not straight, then we go back and we check our working to calculate our point, and we check our working to make sure that we've drawn it in the right place.